GATE 2019 Metallurgical Engineering Question 13. The fastest diffusing element in iron at 1100 degrees Celsius is. There are 4 elements given. We have to identify which element is fastest diffusing element. Now, before identifying the fastest diffusing element, we must understand the types of diffusion that can take place in an atom. The first type is interstitial diffusion and second type is substitutional diffusion. Now, in interstitial diffusion, the interstitial solute atom, it tends to jump from one interstitial site to the neighboring interstitial site. Okay, while in case of substitutional diffusion, there are vacant sites are present in an atom, and these vacant sites tends to aid the substitutional diffusion. So in substitutional diffusion, the atom tends to jump into neighboring vacant site. Okay, so the vacancy mechanism of substitutional diffusion is most widely followed to explain the diffusion mechanism, and these two type of diffusions generally depends on the size of the solute atom. So we need to know the atomic radius of these elements to identify which element follows which kind of diffusion. Okay, like atomic radius. Atomic radius for nickel, it is 149 picometer. For cobalt, it is around 152 picometer. For chromium, it is 166 picometer. For carbon, it is 67 picometer. And for iron, it is 156 picometer. So this is the atomic radius of all these elements. Also, we must understand what is the crystal structure of iron at 1100 degrees Celsius. At 1100 degrees Celsius, iron is stable as gamma iron, or known as FCC phase, also known as austenite. Now, how the phase influence the diffusing mechanism, the rate of diffusion? It is because, if you look closely, these are the octahedral voids that are present in FCC and BCC atom. This is FCC lattice, this is BCC lattice, and these are the octahedral voids that are present in these two phases. In FCC, there are 4 voids per atom, while in case of BCC, we have more number of voids, 6 voids. But the catch here is the size of the octahedral void in FCC is larger as compared to the octahedral void of BCC, whose size is around 15% of the atomic radius. So it means that the octahedral void of FCC is larger as compared to BCC. So the interstitial element can sit more comfortably in case of octahedral void of FCC. Although the number of voids are higher in BCC, but the size of voids is smaller. So the solute atom will find more convenient to diffuse in FCC as compared to BCC due to the larger size of the octahedral void. So here you can see in this image, it is clearly seen. Let us take the case of carbon. Why carbon? Because carbon is smallest of them. If you compare the sizes, the size of carbon is smallest among all the elements. So most likely carbon can occupy the octahedral void in the crystal structure. So in case of carbon diffusion in gamma iron, so the carbon is a interstitial atom because of its smaller size, okay, which sits in the octahedral void of FCC crystal. So there is one octahedral void per atom in FCC, and let us say in case of 100 atoms of solid solution, there will be 91 iron atoms and 9 carbon atoms. Okay. Now that will mean that 91 octahedral voids are available for 9 carbon atoms, which means that only 10% of octahedral void sites are filled, while 90% of the octahedral void sites are vacant and thus available for interstitial diffusion. Which means that for interstitial diffusion, 90% sites are vacant, but in case of substitutional diffusion, like in rest of the cases, we have only limited number of vacancies. Now, what is the vacancy density in a typical atom? It is of the order of 10 raised to power minus 10 vacancies per atom. Okay, that leads to low concentration of vacancies that are essential for substitutional diffusion. So it leads to a general relationship, which is the interstitial diffusion is generally faster than the substitutional diffusion. This is related to the fact that the probability of finding a neighboring vacant interstitial is much higher than the probability of finding a neighboring vacancy for substitutional diffusion. Okay, so the answer for this problem, it is asking the fastest diffusing element. So carbon is the fastest diffusing element by virtue of its size and by virtue of its diffusion mechanism. The diffusion mechanism, the carbon follows is interstitial diffusion. And why it is faster? Because more number of vacant sites are available for carbon to diffuse. While in case of rest of the elements, which are larger in size, so they need vacancy to diffuse from one location to other. For that reason, the fastest diffusing element is carbon by virtue of its interstitial diffusion mechanism. It has been generally observed that interstitial solid solution forms when the solute atom, like in this case the solute atom is carbon, and the solute atom is small enough, that is the radii should be up to 58% of the radii of the partner atom, okay, to fit at the interstitial site between the solvent atoms. Okay, so the radii must be up to 58% of the radii of the parent atom. To know more about this concept of diffusion, kindly refer lecture number 85, Introduction to Material Science and Engineering by Professor Rajesh Prasad, Department of Material Science and Engineering, IIT, Delhi.